Planets are small, really small in comparison to stars, and even our most powerful telescopes aren't good enough to visually identify them. So how do scientists discover exoplanets they can't physically see in the first place? Well, one technique is called the radial velocity method, where a star is carefully observed over long periods of time to detect tiny variations in the speed at which the star moves toward or away from Earth. Because all stars are in orbit around the Milky Way core at various speeds, other stars are constantly moving either toward or away from us, and unless that star has a planet, it should always be moving at a steady pace. Yet, due to gravity, a large enough planet can actually tug against its sun, just enough to make it wobble a tiny percentage of a fraction. Through careful observation, scientists can actually measure this wobble, and by calculating the star's mass, figure out how big the culprit planet actually is. Another technique to discover exoplanets is called the transit method, where a star is once again carefully monitored for a long period of time, and its average brightness is calculated. When a planet in orbit around the star moves between us and it, it causes the brightness of the star to dim by a tiny little fraction. But that's enough for our super sensitive telescopes to detect. Just how tiny of a fraction of a percentage point of light does a planet block? Imagine standing a mile away from a lighthouse as a moth flies across the giant spotlight at the top of the tower. Your eyes will never detect the minute dimming the tiny insect causes, but NASA's super-sensitive computers definitely can. This technique has been used by NASA's planet-hunting Kepler space telescope with great success, discovering over 3,000 planets to date. So once NASA knows that a planet is there, it can tune its most powerful telescopes into the host star and use something called spectroscopy to analyze the incoming light waves. Spectroscopy analyzes incoming light, or more accurately, electromagnetic radiation, and splits it up into various wavelengths, just like a prism splits light into a rainbow of colors. Because of the varying energy levels of electrons and atoms and molecules, each element in the periodic table absorbs and emits only certain wavelengths of EM radiation. As the light from a star shines down on a planet, some of that light pushes through the atmosphere and heads our way. By seeing what wavelengths of EM radiation we receive from a star, we can thus discover what a transiting planet's atmosphere is made up of. So what kind of planets has NASA discovered so far? Well, everything from living hells to some real head-scratchers. 12. Hottest planet ever. Mercury is the hottest planet in the solar system. At a distance of 36 million miles from the Sun, temperatures on the day side reach a scorching 806 degrees Fahrenheit. This makes Mercury a real hothouse. But it doesn't even come close to comparing with Kelt 9b, a planet discovered in orbit around a star 2.5 times more massive than our Sun. While scientists cannot yet measure the distance of the planet from the star, they do know that the surface temperature of Kelt 9b is an incredible 7,772 degrees Fahrenheit. That's hotter than most stars with a lower mass than our Sun. While a rocky planet like Mercury would be a permanently molten ball of lava, Kelt 9b is a Jupiter-type gas giant whose atmosphere is being burned off by its parent star. 11. Coldest planet. With the axing of Pluto as a planetary body, Neptune is officially the coldest planet in our solar system, with frigid temperatures of negative 360 degrees Fahrenheit, where it's so cold that methane condenses into rain. However, orbiting a tiny cool star known as a red dwarf, planet OGLE 2005 BLG 390LB, or Hoth, as it is affectionately known in reference to the Star Wars films, is a complete ice cube at negative 369 degrees Fahrenheit. At such icy cold temperatures, just 50 degrees above absolute zero, the planet doesn't have much of an atmosphere, with most gases frozen solid and lying as snow on the ground of this rocky Earth-sized planet. 10. Largest planet. Stars are heavenly bodies that reach such massive size that gravity in their core ignites nuclear fusion. However, some stars, known as brown dwarfs, are big enough to start nuclear fusion but not large enough to sustain the process. Planet Dennis-P J08233.1-491201b has a whopping 28.5 times the mass of Jupiter, or 9,063 times the mass of Earth. Planet Dennis is so massive that scientists are debating whether it's still a planet at all, or if it should be relabeled a brown dwarf, while the planet itself ironically orbits a confirmed brown dwarf. 9. The smallest. Smaller than Mercury but slightly larger than our Moon, Kepler 37b is the smallest planet ever discovered, a confirmed rocky world that orbits its parent star closer than Mercury does around our Sun, making it far too hot for liquid water or any hope of life on its surface. Kepler 115.03 could be smaller, but little is known about it so far. 8. The oldest. Our universe is 13.8 billion years old, and planet PSR B1620-26b is only 1.1 billion years younger than that. This old-timer is a gas giant that's 2.5 times the mass of Jupiter and is 12.7 billion years old, and it orbits two host stars that rotate around each other in a binary system formation. This old man of our universe is in fact so old that it has outlived both of its stars, a neutron star and a white dwarf. And if that wasn't enough, it's even survived one of its stars exploding into a supernova. Because it's one of the first planets ever formed, this Methuselah world likely doesn't have many of the heavy elements such as carbon and oxygen needed to create life, which was formed later in the universe's evolution via exploding stars. Planets today really do have it easy. Back in PSR B1620's day, a planet had to walk uphill both ways in the snow and survive exploding supernovas just to evolve life. 7. The youngest. At only 2 million years old, the planetary system V830 Tauri is the youngest in our galaxy so far discovered. An astronomical toddler, the host star has the same mass as our Sun but twice the radius, meaning it hasn't contracted fully into its final shape yet. A gas giant with 3/4 the mass of Jupiter orbits this infant star, and it too is likely still evolving, acquiring more mass by colliding with other planetary bodies like asteroids and even gobbling up smaller newborn planets in its path. This evolving system has also not likely yet seen the development of all its final planets, and over the next few million years, remnant gas and dust orbiting the star will either pull together by gravity to form other planets or be swallowed up by Tauri's Jupiter-like gas giant. 6. Planet being eaten alive. Orbiting far too close to its planet star for its own good, planet WASP-12b is a carbon-rich gas giant. Spotted by the Hubble telescope being distorted into an egg shape by the gravity of its sun, its atmosphere is being sucked into its hungry parent star. The host star is eating WASP-12b's atmosphere at the rate of about 189 quadrillion tons per year, with scientists estimating that the planet only has 10 million years of life left. 5. Death by X-rays. When a star between 10 and 29 times the size of our Sun collapses, its core can become a neutron star, one of the densest objects in our universe. Neutron stars are so dense, in fact, that a matchbox-sized lump of material would weigh a staggering 3 billion tons. Their magnetic fields are also between 100 million to 1 quadrillion times as strong as the Earth's, and they can spin as fast as several hundred times per second. Neutron stars emit beams of electromagnetic radiation as they spin, bathing any planets caught in the path with extreme levels of radiation. Planets PSR B127 plus 12a, B, and C all orbit a neutron star that emits deadly blasts of radiation several hundred times per second as it spins, scouring the surface of these planets with radiation so extreme it would immediately destroy DNA. If you were standing on the surface of one of these worlds and somehow shielded from instant death, you would see the star in the sky above you like a disco ball spinning out of control, strobing the sky several hundred times per second. 4. Glass rains. Hot Jupiters are the planets about the size of Jupiter that orbit really close to their Sun, making them, well, hot. Planet HD 189733b is a hot Jupiter with a gorgeous blue atmosphere laden with silicate particles that orbits its star in a whopping 2 days. Imagine celebrating a birthday almost 4 times a week. While the atmosphere may look inviting and similar to Earth's, the winds actually whip around the planet at 4,350 miles per hour and cause rainstorms of molten glass that blow sideways. 3. Darkest planet. A true incognito world, Jupiter-sized planet TRES-2b has an atmosphere made up of light-absorbing chemicals like vaporized sodium, potassium, and gaseous titanium oxide, making the planet reflect less than 1% of light. This makes it the darkest planet ever discovered, and despite analyzing its atmosphere, scientists still aren't completely sure why TRES-2b is so dark. The only light the planet emits is a very faint red glow as a result of its proximity to the Sun, making TRES-2b the stealthiest planet ever discovered and darker than coal. 2. Should have put a ring on it, or a few million. Saturn is the most iconic planet in our solar system, ringed by an absolutely beautiful system of rings made up of pulverized debris and dust. Commonly referred to as the queen of the solar system due to its elegance, Saturn is sadly completely trumped by planet Super Saturn J1407b, a planet 20 times more massive than Saturn, with a ring system that's more than 200 times as large. The ring system stretches 180 million kilometers end to end, which is more than the distance between Earth and the Sun. No doubt beautiful, but perhaps Super Saturn J1407b is making up for something. 1. Fastest. If you thought celebrating your birthday once every 2 days might have made you feel old before, imagine how you would feel if instead you celebrated it once every 10 hours. Due to the force of gravity, the closer the planet is to its star, the faster it moves, and no planet moves faster than Sweeps 10, which orbits its star at a distance of only 745,000 miles, and makes a complete orbit once every 10 hours. Due to its extreme proximity, this hot Jupiter needs all of its 1.6 times the mass of our own Jupiter to resist being torn to shreds by its parent star. Though, like many others, it too will one day be obliterated as its atmosphere is destroyed by its sun. Another speedy exoplanet, PSR J1719-1438b, has an orbit time of 2.117 hours. Despite only hunting for exoplanets for 25 years, our galaxy is already yielding some incredible and fascinating worlds, begging the question of just what else is out there. As our technology and techniques continue to improve, we're bound to discover even stranger, colder, and hotter worlds. If we're lucky, maybe one day we might get a visit. Which world on our list would you like to visit one day? Which of these planets is the most extreme? Let us know in the comments. Also, be sure to check out our other video. Is NASA hiding a planet, Planet X or Nibiru? Thanks for watching, and as always, please don't forget to like, share, and subscribe.